my class. This lecture is on problem solving, and I've divided the procedure into 6 steps. Okay, so let's go through those. The first is to read the problem, visualize in your head what kind of situation is being described, and it's often helpful to draw a picture just to make sure you understand what's happening, what's being described in the problem. Second, identify the question. Make sure you don't waste time, trying to answer the wrong question. And also consider what is the desired form of the answer, and in particular, what units is the answer going to have. Third is to identify the known quantities. Those are things that might either be stated in the problem or else some common knowledge that might be relevant to the problem. Fourth, relate those known quantities that you just identified to the desired answer that you're looking for. Okay, usually that means to find an equation. Okay, once you've got your equation, number 5 is you solve to get your answer. Okay, and you're not quite done actually. There's still one more step, which is to check your answer. Make sure you have the correct units, and make sure the magnitude of your number is reasonable, that you haven't made some miscalculation somehow. Okay, and it's always good to check your math as well. Okay, so let's look at an example. Suppose you have an airplane. It's flying with an airspeed of 600 miles per hour. That means that's the speed relative to the air. And it's flying into a headwind of 50 miles per hour. So the air is pushing it back at a rate of 50 miles per hour. How long will it take the plane to fly between 2 cities 1,100 miles apart? Okay, so first thing is to read the question and try to make sense of it. So I drew a little picture here of the airplane flying. It's got an airspeed of 600 miles per hour and a wind speed pushing back at 50 miles per hour. All right, and the question is, how long will it take to fly 1,100 miles? Okay, so we're looking for the time, the travel time. All right, so what do we know? We know the airspeed, the wind speed, and the distance. We can also determine the ground speed, which is the speed relative to the ground. And that's the thing that's important in this problem because the cities are on the ground. Okay, so the ground speed is the difference between the airspeed and the wind speed. So that comes out to 550 miles per hour. Okay, so that's our ground speed, and then we have a distance of 1,100 miles. All right, so let's look for an equation that relates distance and speed. And we know that as distance is equal to speed multiplied by the time. Okay, so we have everything we need. We just need to solve now for the time. So taking that equation, solving for the time, we would divide the speed on both sides. So distance divided by speed is 1,100 miles divided by 50 miles per hour. So that's the same as 1,100 miles multiplying 1 hour per 550 miles. So the miles cancels, and we get 2 hours. Okay, so let's check our answer here. Is an hour a unit of time? Yes, it is, even though it's not the standard unit. Is the answer reasonable? And yes, for a jet airplane to fly 1,100 miles, 2 hours is a reasonable time. And is the answer correct? Well, we can always take our answer, 2 hours, plug it back into the original formula for the distance, and in fact the speed times the time does give us the correct distance. Okay, so that's a good example of the steps you should take when solving a problem.